Okay, Algebra 1, as promised, here's a video lesson that describes the distance, speed, time triangle. We went over this in detail in class, so I know you've already seen most of this information, but if you wanted to have a video to help you remind yourself what that whole lesson was about, here's that video. It all started because I gave you this do now problem, and we all found that question 3 here was particularly hard to solve. So here it is. If you're driving at a constant rate of 108 kilometers per hour, how long is it going to take you to travel 270 kilometers? Well, the textbook, as I pointed out to you, and you were supposed to read that textbook before you had the do now, gave you example 2, where they talk about this relationship. Average speed is equal to distance divided by time, or they say it more easily, d over t. And then they went ahead and showed you how to solve a problem. They gave you this question about find the average speed of a car going from Idaho, going around in Idaho in something called the Minidoka National Wildlife Refuge for 3 hours. So here's that formula again. Speed equals distance over time. And all they did was plug in those numbers, 180 divided by 3, and they came out with 60. And said the average speed was 60 miles per hour. Well, we talked in class about this same formula, speed equals distance over time, or d over t, and we agreed, well, first of all, it's not always easy to remember that, and second of all, what if I asked you for time instead, or what if I asked you for distance instead? How would you rearrange this? And remember, this lesson is supposed to be about this triangle, the distance, speed, time triangle. And we ended up coming up with a different name, a simpler name, the speed triangle. Or in fact, well, and we said that the speed triangle has d on the top and a division bar, and on the bottom it has s times t. And we came up with a simpler name for it so that we would really remember the shape of this triangle, calling it the speed triangle. I've underlined the first letter of each of these three, d and s and t. And I hope that'll remind you to put the D, which is the first letter, at the top, and that the S and the T are the ones that are multiplied. And the way we use this is if I want to find T, I'm going to cover that up, and then I'm going to do D divided by S. If I wanted to find S, I would cover that up, and I would do D divided by T. And if I wanted to find distance, I'd cover that up, and what would be left would be S times T. So here, let's use that problem that we looked at. If you're driving at a constant rate of 108 kilometers per hour, how long is it going to take you to drive that far? 270 kilometers. Well, this is a how long question. This is a time question. So I'm looking for time. So I do have the other two pieces that I want. I have the distance, which is 270 kilometers, and I have the speed, which is 108 kilometers per hour. And there they are. So like I said, I cover up time. And so now time is equal to these two pieces, distance over speed. I plug those numbers in. I just said that distance is the 270 kilometers, speed is the 108, but make sure when you do this that you write down the units. That's the biggest problem students were having with this whole speed triangle, was the fact that they were losing track of the units. Make sure you write them down. Now remember, I've said before, one of the most enjoyable things about writing down units is canceling them out. Well, those kilometers both cancel out, and I'm just left with hours. I plug this into my calculator, and 270 divided by 108 is 2.5. And again, my units, the only unit that was left, was hours, which makes perfect sense with time. So that's my answer to that one. A second question, and we talked about this in class. Last weekend I really did drive for 6 hours on the highway, and my average speed, let's say it was 70 miles an hour. So how far did I drive? Well, how far is a distance question. So distance is what I'm trying to find, which means I'm going to look for speed times time. I'm going to cover up distance. Good news is I do have a speed, 70 miles an hour, and a time, 6 hours. So those are there. And I set this up. Distance equals, like this says, speed times time. I plug those numbers in. 70 times 6 But once again, I remember to put in units. So it's not just 70, it's 70 miles an hour. That's speed, remember. And time is 6 hours. Now, once again, I cancel out units that I can cancel. The hours go away. I'm just left with miles, which is good news because I have a distance question. And now it's just a matter of 70 times 6, which is 420. But don't lose track of the units. It's 420 miles. That's how far I drove. That's the answer to that question. Third example we talked about in class was about Usain Bolt in the Olympics. He ran the 100-meter dash in about 9.6 seconds. I could be wrong about this. This is what I remember. What was his average speed? Well, I'm looking for speed. So I'm going to cover up speed. It's going to be distance divided by time. I've got a distance, I've got a time. The distance is 100 meters. The time is 9.6 seconds. So speed is going to be distance over time. It's going to be 100 meters over 9.6 seconds. And that turns out to be 10.4 meters per second. An interesting answer, and it would be exactly what the textbook would tell you. But it doesn't really tell me a whole lot because I don't really have a vision of what 10.4 meters per second really looks like. So let me ask you a question. Let's use that unit analysis that we were talking about in class. Okay, speed is equal to 10.4 meters per second, but what I'd like to know is, what is that speed in miles per hour? Now, miles per hour I understand, whether I'm on my bike or in my car. I've got an image of that in my mind. Well, to do unit analysis, I said in the classroom, and I'll remind you, set it up so that your answer is the first thing, or the units rather, of the answer are the first thing you want. Well, it tells me right here what the units are supposed to be of my answer. It's supposed to be miles per hour, so write that down first. My speed is eventually going to be my miles per hour. The next thing you do is you put in any information you have. That's the only information I have, so I put it there. Somehow I'm going to turn meters into miles and seconds into hours. By the way, when you set this up, make sure that the answer units you want match the answer units you put in. So miles is on the top, another distance, not the one I want, but a distance, meters is on the top. Hours is what I want, and another time unit, seconds, is on the bottom. So these match up, hours on the bottom, seconds on the bottom. But that doesn't help me a whole lot. I'm going to have to find a way to cancel meters and cancel seconds to get miles per hour. So I would tell you, if I gave you a problem like this, the conversions you would need, and here they are. An hour is 3,600 seconds, a kilometer is 1,000 miles, and a mile is 1.6 kilometers. So now all I need to do is plug each of those in. 3,600 seconds per hour, like I said, a kilometer per 1,000 meters, and so on. Notice I'm multiplying each of these things. When I'm doing conversions like this, I just multiply it out. Now I get the fun of canceling. First of all, the meters go away. Now the seconds go away. And lastly, the kilometers go away. And I'm left with the units I wanted. I wanted miles per hour. The only units that aren't crossed out are miles per hour. I'm going to clean this up. Notice I didn't bother writing, the times 1 and the times 1 here, or the 1 hour. I just wrote the other numbers. 10.4 times 3,600 was all I had on the top except for ones. And on the bottom, the only numbers I had besides ones were 1,000 and 1.6. Put that into your calculator, and you're going to find that it's 23.4 miles per hour. And that's a much more helpful image to me for how fast Usain Bolt was sprinting at the Olympics. Okay, that's it. I gave you a homework sheet on the website, and with this video, and certainly with the lesson that you had in class before the video, you should have no issues, I hope, with the homework. But if you do, by all means, come in, let's talk about it, and let's get those things straightened out.